Good afternoon, everyone. Welcome to the Faculty Development Program. It is my privilege to introduce Dr. J.D. Chaitanya Kumar Sir, an Assistant Professor in the Department of Civil Engineering at KL Deematubi University, Vijayawada. He has a PhD in Civil Engineering from JNTU Anantapur, an MTech in Structural Engineer from GVP College of Engineering, and a BTech in Civil Engineering from SRK Institute of Technology, both affiliated with JNTU Kakinada. Sir has 11 years of teaching experience both in India and abroad. He previously served as a lecturer in the Department of Civil Engineering in Debre Bahran University in Ethiopia, where he made a significant contribution to the field of civil engineering education. His research interests are focused on sustainable construction materials and their structural behavior, with a particular emphasis on utilizing agricultural waste to develop lightweight concrete elements. He has an impressive research portfolio with 44 Scopus Index papers and 2 patents. His work has significant recognition reflected in his H index of 13. In addition to his research and teaching, he is a reviewer of reputed journals and a member of the Indian Concrete Institute and the Pre-Engineered Structure Society of India. Sir has actively engaged in the academic community, participating in numerous national and international workshops, conferences, symposiums, seminars, webinars, guest lectures, and training programs. Please join me in welcoming Dr. J.D. Chaitanya Kumar, sir. We are honored to have you with us today, sir. You may start your presentation now, sir.
Yeah, thank you, Divya. Am I audible?
Yes, sir.
Yeah, okay. So thanks for nice introduction. Let me share my screen. So now the screen is okay.
Yes, sir. Visible.
Yeah. So good afternoon and all. Due to some unavoidable circumstances, today's afternoon speaker so is not unable to join. So meanwhile, the same area of the interest, I'm also working in the same area of interest. So that's why I am able to take the session. So today I want to talk about utilization of oil from corn shell. That means your palm oil shell we are using as a lightweight aggregate. So in the by using of this agricultural waste. So actually, whatever we are using as the palm oil is agricultural waste. So by using of this agricultural waste, now we are going to produce a concrete. Okay, lightweight concrete. The density will be varies from 1800 to 2300 kg per meter cube. So by using of this, my actual motto is to develop the lightweight concrete for the industry of precast. So why we are going with the precast industry? So when you are having the heavy structures, when you have heavy structures, to lift the heavy structures and we have to place in the given position. So there is a humorous task will be there for the machinery and all. So to avoid that humorous task and all, so we are going to reduce the weight of the element itself. So that structural lightweight element will can use for the structural purpose. So will my aim is to use this concrete in the precast industry that we already succeeded and I produced my I uh, that, done my PhD in that area only. So I will give the brief introduction about this one, and after that I will show my PhD work as a case study. So let me take the introduction now. So this my entire presentation will be looking like this. So introduction, physical properties of the palm oil shell as aggregates, maybe fine aggregate and the coarse aggregate, and mechanical properties. Mechanical properties means so you have composition, tensile strength, and flexure strength. Okay, so flexure strength without reinforcement and durability studies and functional properties of the formal shell and time dependent properties and structural behavior. The structural behavior here we are showing as a beam, column, beam, slab, and frames, portal frames. And the comparison of your formal shell with the agricultural waste, other agricultural waste means, for example, if you consider the rices cash also agricultural waste, and your coconut shell as agricultural waste. So some cases I will show, and after that we will close the session. So let me go with introduction. So actually, I told you in the starting itself why we are going to this aggregates as the lightweight aggregates. So coming to here, we are having the industry, construction industry. The entire construction industry is mainly depending on the concrete. Okay, so when you are going with the conventional concrete, the structural weight will be increasing nowadays very, very, very high. By we are using natural aggregates as a 80% of your concrete will be your aggregates only. It's combination of fine and coarse aggregates. So and also we have so many waste are developing from the industry agriculture waste. So why don't you use this agriculture waste as a replacing of your aggregates? So we in the 80% of the volume is there, so we cannot replace entire 80% of the volume. So we can replace at least 50 to 30% of volume of your concrete aggregates. So by using of this idea, we started this work actually. So during the last 10 years, you can consider here. So the oil palm shell and oil kern shell using as researchers as lightweight aggregates and in the replacement of normal weight aggregates in the structural elements and the road construction, especially in the African countries and also in the Malaysia, people are using this type of aggregates, the 100% replacement in the low income group houses. Okay, so here we are going to use this as a industry called as precast industry for replacement of this aggregates. So see here when we have the population growth in India, we already crossed China, right? So to meet the demand for the who are there in the public, so to give the basic needs like food, accommodation, clothing and all. Food and clothing will be very cheaper compared to the accommodation. So to give the accommodation, we need at least low what do you call we can reduce the construction cost of the house, right? So in our governments also we are they're producing so many houses for the low income group people and poor people. So this is the one of the idea we can develop in the here we have to use this aggregate in the replacement. Okay, so here India population is increasing every day by day it is increasing. So we can take here last year it is increasing by 1.11 percentage of growth actually. So in the case of here we are replacing the palm oil shell. So here what happened with the palm oil shell actually? So after extracting the palm oil from the palm oil fruit, the dump is putting in the barren lands. Okay, so every year you can consider the India itself 600 metric tons of waste is generating from the this industry. Okay, so next the major oil palm producers are producing the oil palm shell as well as the oil. This oil palm shell they are using as the replacement. What they are doing actually, this oil palm shell they are dumping in the land, and also some of the people using as this as a fuel for the boilers. For example, if you consider in the sugarcane factory, they have to run the boilers. So for running the boilers, we uh, need some fuel, right? For that fuel, what they are doing, they are using this as a fuel. This shell is using as a fuel, but after burning of the shell, what happened? The ash is coming, like your fly ash. Same that ash is not that ash. What happened? That ash will be again polluting the air. So to reduce all these pollution problems, like your barrel land, they're dumping in the shell as a vacant land and all. So that groundwater pollution will be there, and also we have air pollution will be there. To reduce all these things, we came to one solution that we can use this replacement, this shell and cement will be replaced with the palm oil fuel ash, and palm oil shells will be replaced with the coarse aggregate. Some of them are using as palm oil trees are also using as the fine aggregate replacement. So actually, how the palm oil shell and palm oil shells and palm oil fuel ash will be producing. See here, this is the chart is giving here production of the oil palm shell and oil palm clinker. So here we can consider here you can see the right side of the tree is looking like a our coconut tree, right? So for coconut tree, bunch of fruits will come. Same in the case of here also, palm oil fruits will come that we can call it as palm fruit. From the palm fruit, they're having bunches of palm fruits will be there, right? So after opening that bunches of the fruit, we'll get the outside shell. That shell we can have the sports aggregate that is palm oil shell. So after that, what happened? They are using as the some of the shell into the boilers fuel. So after getting the burning of the shell, we'll get the palm oil fuel ash. So these are the production of your our palm oil clinker, palm oil shell, and palm oil fuel ash. These are the three types of waste products we are utilizing in the we are utilizing in the construction industry. So there is a significance also we can consider here. So there is a research significance. First of all is to reduce the pollution, groundwater pollution, and also uh, air pollution. Second one is the you can reduce the sexual weight in the construction of precast industries, and we can go with the cost effective also, and we will reduce the mass of the entire building, and there is thermal insulation will be there, and sound insulation will be there. If we go the in deeper in the further slides, I will explain that one. So we can use the what are the minimum. First of all, we have the physical properties of the oil palm kernel. Okay. So in the mechanical properties of the hello, Divya.
Yes, sir. You're audible, sir.
Okay. So slides is moving. Now we are the physical properties.
Research significance of students. Yes, sir. It is visible. Physical properties of work. So your voice is not audible, sir.
Now it's okay.
Yes, sir.
Okay. So now we'll see the main physical properties of the shell as an aggregate. So now we'll go with the mechanical properties of the oil palm shell changes depending upon the physical properties of the shell, right? Whatever the concrete you can take, it depends upon the main physical properties of the concrete only will depends upon your mechanical properties, right? So in this case, the texture and shape of the shell will be very uh, uh, you can observe here the shell and shape will be the like your coconut shell only, and it is some less compact of bulk densities will be there, and we have the main disadvantage of this shell is water absorption. Okay, the water absorption is more. We have some methods to reduce the water absorption also. So the water absorption you can go with the PVA solution. Coating with all your shells, you can coat it with the PVA solution. Polyvinyl alcohol will be there that we can coat all the shells and we can use this shell. So and also we can use the you can use this shell as the you can soak in the water before the day before using out the concrete. We can go with the optimum temperature. That means we can open the sunlight. It will give the moisture content will be reduced. So shell having the enough water is given already. So after that we can use this shell in the concrete production. Okay, so the specific gravity also it's very will be very less compared to the your coarse aggregate fine aggregate. So it will be varies from 1.17 to 1.62. So we have the wide range of shells will be there, particles will be there. You can observe in the this table. In this table, you can observe here the previous results are given the specific gravities. You can observe the specific gravities. It is varying from 1.372 and 1.62, right? So actually, our coarse aggregate and fine aggregate will be specific gravity will be more than two, right? So we this is the less specific gravity, and the bulk density also will be less. And bulk density when you have the loose uh, volume and the compacted volume also very less. So here you can observe here the moisture content. The moisture content will be so it's varying from again 8 to 15 percentage, and the water absorption will be having more than 27 percentage, and some places 33 also. So this is the only problem with your water absorption. The porosity also very high compared to normal aggregates. You can observe here the particle size distribution of the palm oil shell is given here, and normal sand also is given here. So here, why we are showing the normal sand here? The shell, what we are getting, the waste product, less than point 0.4, less than 4.75 mm clinker, we can use as the replacement of sand. So next figure is showing the dumped palm oil shell at the factory site, and you can observe the shape and sizes of the palm oil shell. It is looking like a small sizes of your coconut shell. Okay, so this is the case. We can take the shell figures and shape and sizes. So now coming to the slab shape and thickness of the shell here, you can observe here the thickness of the OPC will be varies from 0.17 to 8 mm. Uh, it's varying from 0.5 to 8 mm, right? So when we have the 20 mm aggregates we are using, right? So the 20 mm aggregates we cannot replace here. So that's why when you are using as this shell as a aggregates, we can have to replace the aggregates of 12.5 as only, 20 mm aggregates. Okay. So in the bulk density also is very less compared to the other concretes. So the bulk density will be 600 to 1600 to 1900 kg per meter cube. So what I told in the previous slide also, the water absorption will be very less compared to very more compared to the normal aggregate. So, but we have a other aggregate that is called pumice aggregate, that also people are using as the lightweight aggregate. But that the specific the water absorption will be 37%. But compared to that, it is very less. Okay. So now. So now the plastic density also, it is varies from 1910 to 1958. So that is that depends upon the your mix proportion. For example, we are using as a replacement of 100 percentage. So the density will be less, and we can replace in 0 to 100 percentage. But actually, we cannot suggest the replacement of aggregates with this shell not more than 20 to 30% only. If we are replacing more than 30 percentage, we cannot achieve your uh, target shells. Okay, so next coming to the density of the hardened property, hardened concrete. The hardened concrete, the density already I mentioned here, 1800 to 2300 it will be varies. But as per here, we can go with the 1800 also for low like production of lightweight concrete. Okay, so these are the some of the researchers are given the values. Densities is varying when you are having the SSD condition. SSD condition is nothing but your surface saturated dry condition. That is nothing but whatever we are using as the coarse aggregate as a formal shell 8 to 12 mm diameter that we have to soak before the using of concrete. After that, we have to put it in the one open to sky. That means when you have to give the sun, directly sun. After that, 1 hour or half an hour, we have to use that aggregate. That is called SSD condition. So when you have SSD condition, the density varies from here 1630 to 1960. And also we have oven dry condition is there. The oven dry also we have 1639 to 1775 and 1965 also. So different people are using as the different types of drying conditions by using for the density calculation. So they are the different researchers given the values. So depends upon your water cement ratio also. Your density will be varies here. Why already we have enough water content in the shell. Okay. So coming to your main property is the mechanical properties of the formal shell. The main property of the mechanical properties is we have to calculate the Young's modulus. The Young's modulus value will be previous before that we have to calculate the composition, tangential strength, and uh, flexural strength. That is modulus of elasticity value. Okay. The reason for both fine aggregates and shell contents plays a major value for the calculation of Rice modulus values. Okay, so that depends upon the mix design and curing conditions. Different researchers have different found the some grades are given here. You can see this table. So this is the major invention in the formal shell industry. So you can see here the water cement ratio. The water cement ratio is varies here 0.64 to 0.8. So this is the main role here. So there is a next column is mentioned here, the mixed proportions. The mixed proportions are given here 1 is to 1.5 is to 0.5 is to 1. Like that, they given the slump values also given. And if you are having, observe here, when you have water cementation is high, the slumps are here, shown here, the collapsible slumps. And also here, the composition values are given here. You can observe here 22.20 and 20.50. So this much and strength is enough for your construction of low income houses. And if there is a corresponding flexural strength and tangential strength are mentioned here. So all these things are given by the previous researchers. So this is also you can observe here. Here they mentioned Young's modulus values also. The Young's modulus also here given black column. So these are the different types of conditions. So here we can use in addition to your formal shell replacement, you can go with the replacement of cement also by using UBS, rice cash, formal fuel ash, fly ash, and all. So whatever you can available depends upon your research work. You can replace the materials with different types of mineral admixtures. Okay. So here durability. Durability also we have to check the major criteria for the replacement concrete. So you can observe here the water absorption is defined as the transport of liquids in the porous concrete, porous solids caused by the surface tension. That will be water absorption will be for particular research is mentioned here 11.23 and also uh, so there is another research. You can observe here the figures which is present in the right side of the slide. So you can observe here the water permeability value. The water permeability value can measured here by using of permeability operators in the Yale University laboratories. So these are the less permeable over the time. After age of 28 days, the OPC and the TC curing. That means under the controlled curing values we mentioned here. The controlled curing is possible in all our laboratories. So let's come into the micro studies. So in the micro studies also you can observe here the pores will be closed by when you are using in the replaced concrete with cement. Okay, high water absorption is there and 16 to 24 micrometers or convex pores will be observed here. Why convex pores is observed here? We have the shape of the your aggregates will be convex surface. So when you have the convex surface is more, you can observe here the pore size is also mentioned here. Okay, so here they use in place of cement they use a particular figure they use 10% of silver also. Okay. So next, initial surface absorption. The surface absorption will be depends upon from 6 days to 18 days in the water, and also we have primary reason for that because the high surface absorption, the shell and high porosity of the cells, and we have you can observe this figure. Okay, that is not here. Okay. So next, coming to your thermal properties, there is functional properties of your shell concrete. So indicate the conditions of heat to the material. For example, if you go with here, this is the functional properties of the aggregate concrete. That means shell concrete. The thermal conductivity also depends upon your pores in the concrete. So to avoid these pores in the concrete, we have to go with the different mineral admixtures in the concrete. So the different mineral admixtures will be we have GGBS, fly ash, rhesus cash, metacolin, and we have formaldehyde also. So if we reduce this pore size, we can reduce the thermal conductivity values also. So this is very important for the replaced concrete when you are having the agro industrial waste. Okay, next coming to your sound absorption. The sound absorption also sound absorption of coefficient increases with the increase in the water cement ratio for the same mix of the concrete. So if you increase to maintain the same mix for the high rate of water cement ratio, you can sound absorption also will increase it. Okay, so noise reduction also we can it is found to be 0.34 to 3.5, 0.35 for the water absorption, and for 0.5 and 0.6 also you can observe here. So the noise reduction coefficient will be 0.02 for the normal concrete, and BCD is 0.5 to 0.6 for the replaced concrete. So this is very important for the sound absorption cases also. The high reduction coefficient for the shell replaced concrete mainly due to the more force in the concrete, and also the shell will be in the entrapped air action to the insulator. If you have any force will be there, that force will be occupied with your air. So next will be the time dependent properties, that will be creep and shrinkage values. That creep and shrinkage values also we can go with this concrete. It will be very useful for the construction industry. So next is the shrinkage values also. The shrinkage value can be used, can be calculated by using of the prism sizes of will be 50 by 50 by 250 m3 concrete specimen, and also initial length of the concrete will be at least 44th of your relative humidity value. The relative humidity values will be also can be calculated by using of this concrete. So these are the shrinkage properties. Next will be the flexural behavior. The flexural behavior of the concrete we are calculated by using of the beams. Okay, so 1.5 meters beams with casted here. So for example, consider here six beams are considered. Three beams will be singly reinforced, and three will be tested in the double reinforcement, and vertical circular tracks will be observed. So when you are testing in the 2-point loading, that means field bending loading. So in the field bending loading, So whatever we are applying the load, so you can observe here the vertical flexural cracks. The vertical observed in the constant movement region. So when the constant movement region, we are applying the load, that the 2-point load is applied, right? Below the 2-point load, you can observe the clear mentioning of the constant mentioned region. So since all beams are under reinforced and yielding of the tensile reinforcement occurs before the crushing, and so this is common. So whatever we are testing as the regular concrete, what are the shape, what are the deformations and what are the cracks developed, same will be observed in the this type of concrete also. We can and we can also plot the stress strain behavior also by using of this load versus beam deflection graphs and all. Okay. So when you have the reinforcement will be here using a 3.14% unless an ultimate moment obtained from the experiment is the 4 to 35% of the higher compared to the predicted values. So the predicted values will be the theoretical values only. Okay. So these are the values which is observed from the replaced concrete with shell. So here, the shear behavior. So this is very important here. So why shear behavior is that much important here? So you can observe the figure is mentioned here. So at the early ages, that means before 90 days, at 180 days, the cracks are passing to the, where we have the gap between the shell to shell. So what happened after that? This is a very disadvantage here. So what happened here after later ages? That means after 180 days, after 270 days, what happened? When you take the concrete specimen, the crack is observed in the through the shell. So this is the disadvantage actually. Okay, so there is a bond strength also there. That bond strength also weak with this shell concrete, and we can compare this concrete with different agricultural waste. The different agricultural waste we can study it here as the clinker values and ricer's cash values and cocoa and shell values as a concrete. Okay, so for example, you can consider here the ricer's cash. Okay, so for experimentation results, researchers could conclude that the concrete made with the ricer's cash has the lowest bulk density, that means 136 kg per meter cube, and the lowest compressive strength and tensile strength. So compared to this, we can use our replaced concrete shell is very good compared to this concrete. So these are the one example we can do here. You can observe the water absorption ratio also and the composition also. The composition will be varies in the 28 days composition, 5 to 27 MPa. Already I showed this values in the previous research values. So the replacement. So here OP says the partial replacement as the fine aggregate coarse aggregate. So people have attempted this replacement from with the interval of 25%, 0 to 25, 30, 0, 25, 50, 75, 100 replacement. If we increase the value of shell content is definitely the composition will be reduced. So that's why we limited to use of this 20 to 30% of replacement only is possible to get the structural stability and to get the desired composition values. Okay. So now we can go with some case studies. The case study which is I done my PhD work that I will show in this slides now. So here, so I consider here M30 grade of concrete. So in the M30 grade of concrete, what I done here, first of all, I taken the 30 M30 grade concrete as the conventional concrete. So second concrete will be concrete with same M30 grade concrete glass fibers I considered to reduce the cracks also. So next, that is the first pilot study. After that, what I done, so I went to the replacement of shell and the cement at a time. Shell I am using as a coarse aggregate 10 to 50%, 50. That means interval of 10 I used, and also cement replacement with your palm oil fuel ash, and also I went to GG base also. So I here two types of studies are there. First of all, first study will be replacement of shell plus cement with sorry aggregates in the shell place, shells in the aggregate place, GG in the cement place. Second case will be same in the case of first case. What happened? Coarse aggregate I replaced with shell plus cement I replaced with palm oil fuel ash. So this is the case considered for the mixed design. So for that, what I done the calculations, mechanical properties I went, composition, tangential, bending strength, that is flexural strength without reinforcement. I went for the durability studies. The durability studies will be your acid attack, fluoride attack, and sulfur attack. And flexural studies, I went behavior of beams and frames Next will be the portal frames. I consider the portal frames and also precast frames and precast frames I went. So next will be the analytic analysis. Same, what are the elements we cached in the experiment? The same I cached in the same I modeled in the Abacus software. Next will be the micro analysis. Same XRD, DAX, and FTIR values. These are the materials I used for my study. So following materials I used. Binding materials will be cement, GG base, and formal fuel ash. Aggregates will be river sand and gravel and formal shell, and the glass fibers I used ECR glass fibers, and water as for bonding purpose, and the admixture also I used to maintain the slump. The contrast SP430 used for the uh, admixture. So here I went the specimen size like this, and the standards are mentioned here. The composition and composition will be normal cube, that is 150 by 150 by 150 cubes. I went. I taken the sample size will be 150 by 150 by 150. Fill tensile strength will be 150 mm diameter and 300 mm length of the cylinders. And the bending strength will be 500 meters, 500 mm by 100 mm by 100 mm cross section I taken. And I went for the stress strain behavior to attempt the H modulus values due to some unmodeled circumstances. I didn't calculate the E values. Okay, so all these tests are done for the 7 days, 28 days, 60 days, and 90 days, and 365 days also I tested. Why we are using as a agricultural waste, right? So some people told me that agricultural waste may be decay after some days. So we went for the 1 year test. Whatever the day one, the shape of the shell is there. At the end of the year also, the shape of the shell is same in the case of it is not decayed as a values of shape and sizes. Okay. Next, coming to the durable studies. In the durable studies also, I went acid attack, solar attack, sulfur attack. The specimen size will be so 150 by 150 by 150. So here also I maintained the pH values of the acidity 2.8. Sorry, HCl is 2.8 and sulfur attack is 2 and the chloride attack. So what is the percentage we use here? 3% for the acid, 5% for the sulfates and chlorides. So this what happened? First of all, we done the we cached the specimen. After that, hardened after the uh, final setting time is finished. We went for the 28 days of normal curing first. After 28 days of normal curing only, we went for the acid attack, chloride attack, sulfur attack test. So next we went to the microstructure analysis. The microstructure analysis also we went for the SEM analysis, and the SEM analysis we can check here. The left side is given here. We mentioned the voids. What is the voids we observed in the SEM analysis, and the pH gel formations, and we have so all other elements are mentioned here. After that, FTL values will be there. The FTL values we can plot it in the wave numbers and transmission values, and also we can go with the XRD values also. The XRD values also is present here. XRD graphs also presented here. Next, I went for the two types of cross sections of the beam. So 1.5 meters is the kept constant. After that, the width also kept constant at the 150. So depth is varying here, 150 once and 230 once. So we went for the testing of all these beams by using of loading frame, which is having 200 tons capacity in our university. So I used this loading frame. So this loading frame, we went for the testing of field bending cases. So these are the outline of my testing of flexure beams. Next, coming to the slabs. The slabs also we went for the 4 inches discontinuous slab, and thickness of the slab will be 100 mm, and 1 meter by 1 meter slab we used for the testing of this concrete. You can observe the cracks, crack patterns and all. So next will be we captured the monolithic frame. The monolithic frame having the sizes will be 1 meter by 1.3 meter. So the clear column to column size is 1 meter, height is 1 meter, and we consider the cross section will be 150 mm by 150 mm. You can observe here the uh, reinforcement detailing of monolithic frames. They are the chassis specimens when you are testing the laboratory, that is loading frame. So we provide the hooks for the lifting purpose. So after that, we selected the frame from the loading frame. After that, we went for the testing. So next, coming to the precast frames. The precast frames also we casted in the same laboratory. So columns will be separate and the beam will be separate. For column to be given the corbel connection to rest the beam. So here we consider here, you can observe here, right side end picture, there is a pipe here connected. This pipe will be for double bar. So after electioning of the columns, we have to connect this beam to the column. For that purpose, we went for the this double bar connection, the precast connection. So you can observe here the catcher placements and while during erection and while during jointing of beams and frames. So these are the main critical part of my research work. So after that, we this is the text and all we connected. So by using that entire research, I can say that we can replace the concrete by the shell and the palm oil free lash, but the palm oil free lash we can replace up to 30% only, and also we can replace the palm oil shells in the concrete up to 20 to 30% only. So then only you can achieve your target strength. If you are increasing the shell, we can reduce the density, but we cannot achieve the composite strength, tensile strength, and durability and flexor strength. Okay, so this all about my presentation. If you have any doubts, you can contact me now. You can ask me now. These are my contact details. You can contact me if anytime. Divya.
If everyone have any questions, you can feel free to ask in chat box. So there is a question. What are the
Yeah. So
challenges
you
while
need pre-treatments of OPS before using the concrete. So we have to treat your aggregates to reduce the water absorption. We have to go with the PVA treatment. That means polyvinyl alcohol will be there that we can melt in your water and go for the heating till you get the consistency. After getting the consistency, we have to coat these PVA with your shell. Then only you will get the bonding, and also it will reduce uh, the water absorption. And also, what are the challenges while doing this practice? So, main is the water absorption, and also we have faced the problem with segregation of, that means uh, CVANs. We have to done CVANs before going to the before using this one. Why? It is aggregates, right? So these natural aggregates. It is having so many debris, so much of waste will be there. We have to segregate your shells before using the concrete. Any other questions?
Okay, sir, we'll wind up the session. Thank you, sir, for the thoughtful and enlightening presentation on the utilization of oil palm kernel shell as lightweight concrete aggregate in concrete. Your analysis of using agricultural waste has opened new ways for sustainable construction practices, sir. Your research and experience in this area have provided us with the solid foundation to further implement these sustainable practices in our own work. On behalf of everyone present here today, once again, thank you, sir, for the time to share your valuable knowledge.
Thank you, Divya.
You may leave now, sir.
Okay.